Hey students, Rich, Pappy Johnson here, ready for another lesson? Today we'll be looking at schematic wiring diagrams and symbols. So this is a typical schematic wiring diagram for a dryer. My test dryer is called Toasty, and this is the diagram that goes along with that gas dryer. Now, one thing I'll point out here, and this is a Whirlpool dryer, they give you two diagrams on their sheets. This upper one is for a 240 volt electric heat dryer, and I'll show you here. Here is the heater. That's a resistor symbol. And then the bottom section is for a 120 volt gas heat dryer. Now this uses a burner system, a gas burner system, and here are the symbols that are within that. We'll learn about those later. Today I want to look at the diagram itself and kind of get a feel for how this works. We'll use just the lower one because that's the dryer that we will be working on. And we'll start up at the top here, and you might recognize this from last week when we were repairing lamps. Here is wiring to a drum lamp, and this lamp turns on when you open the door. So here's a wire. The reason it's dotted, by the way, is this is an optional feature on the dryer. So we have line 1, it's identified here, L1, telling you it's a black wire, and we have one wire coming in to the drum lamp. And here's already an exception to what I told you in the past. Usually switches are located on the line side. Here's our load, our drum lamp, our wire, and it's directly connected to L1 to power, no switch. On the other side, you will see the dotted line goes to a switch here. Now, this is a single pole double throw switch, but mainly what I want you to look at here is the light switch part of it. You can see that switch is in the open position right now. And then the white wire goes back to neutral. So this is identical to the lamp that we looked at last week. So you have one line coming in to the switch, through the switch when it's closed, over to the lamp. And on the line side, we have line 1 coming in to the other side of the lamp. The lamp lights up. We'll go into a single pole double throw switch because it's fairly common with door switches. And the way it works is, there's a common side to the switch. In this case, that common happens to be neutral. So neutral comes into this side of the switch. And instead of just on or off, what it's doing is going one direction or the other direction. And it usually is on the left, going through switches, switches, switches. Notice how everything is just a switch or power and then a device. You have power coming in from the house, so you have power, you have a pathway, and you have a load. And the load in this case, there's a few. This timer motor is a load. This drive motor that turns the drum is a load. Loads are anything that creates heat, light, or motion. So this drum lamp is a load. So again, we have incoming power, we have the connectors, usually with switches in them, and then we have the loads, the motor, the drum lamp, and also this burner assembly. It includes all of these components here For schematic purposes, they're singled out, but this is all one piece of equipment in the dryer. So if you look at some component from a standpoint of figuring out what's wrong with something, if you look at a single component, say like this motor, the idea is that you can trace back to where power should be coming from. That's the line side, and then on the neutral side, from here, back through the door switch, and also notice this push to start switch. It's the same symbol as a switch with that little bit added there that shows you that it's a push to start. You'll notice some different switches like this one. This is a switch, but because of the unusual shape, you know it's actuated by something. In this case, it's actuated by temperature. It's basically still just a switch, but instead of somebody pushing a button or turning a switch, it is activated by the temperature, and it gives you those readings here. Here's another thermostatic switch. It's just a switch that's activated by temperature. So here's a normal switch. It's inside the timer, but it's a normal switch. Then a temperature activated switch, and another temperature activated switch. So if you were looking at the path to this burner assembly, again, we start up here at L1, that goes to the power cord. You can see that here. Here's the 3 connections to the wall, 120 volts, line 1, and neutral. So we have line 1 going down through the timer switch, through this safety thermostat switch, through another thermostatic switch, through a fuse, and then to the burner assembly. That's the line side. From the neutral side, the neutral path to the burner assembly is a tiny bit different. It goes from neutral, well, let's start at the wall, out of the wall to neutral, through the door switch, which is closed, down here. Notice this switch is open. That's the push to start switch for the motor, which is only on when the motor is to be started. So the neutral is coming here and stopping. It does, however, go this way, and in this direction. This is also a switch. This is called a centrifugal switch, and this weird symbol here next to it says that that switch activates when the motor is turning. It's kind of a safety switch because it won't allow the burner to come on unless the motor is turning. So once the motor is turning, then this switch closes. So now we have our neutral path through that switch to the neutral side of the burner assembly. So with L1 and neutral to the burner assembly, it will start its process to light the gas and turn the heat on the dryer. I want to back up again here, and if we had a lamp that didn't work, just like last week with the lamp that we tested, you know, we can check with our ohm meter. We turn this to ohms, and then we hit the select button so that we have ohms and not M ohms. That you read down at the bottom, that's the ohms signal or symbol. To check continuity, we would go from the plug of the dryer to this side of the drum lamp, and then making sure the door is closed, so this switch should be closed. We can check, and this is without electricity, we will check from the plug on the dryer. So one lead goes there, to this lead on the lamp. And if we have continuity, that means this wire is good, this switch is good, and there should be power here. To confirm that, we would actually do a live test, and we'll turn this to volts AC, volts alternating current. We would shut the door so the switch is closed. Excuse me. We would open the door so the switch is closed. And we would test here for 120 volts. If we have 120 volts here, the lamp should be on. So if the lamp's not on, it's either a bad lamp or possibly a bad terminal inside the lamp socket or something like that. That's all for today. Have fun. Keep learning. Well, thank you, students, for taking the time to watch this video. I hope you learned something from it, and I look forward to seeing you guys again soon. Take it easy. Have fun. If you have any questions about the things that we discussed in the video, you can leave the comments at Pappy's Secrets YouTube or email your teacher. Thanks again.